Hi, this is the demo for the Project ConsertBuddy final submission. I will be demoing the enhanced microservices implementation, the single sign-on, and the front-end UI. Let's get started with the enhanced microservices implementation. In our system, there are three main microservices. First microservice is the user microservice. There are two domain models, the users and the songs. Let's get started with the user. If we want to create a user, we can just use the post API, and we have all the information of the user here, and we post it. It's gonna create the user for us. We can get the user we just created using the get by ID, and we have the user here. We can also use the get you all the users, but that's a lot of users, so we implemented the filtering here. That is only to show the users with the name provided. So we just provide a prior parameter. For example, if we provide the prior parameter Peter, that is to show all the users with the name Peter. So if we execute it, it's going to do the filtering, and it only shows the user with the name Peter. And with the Josh we just created, and for example, we add Josh at the prior parameter, and we do the get all the users. It's only going to show all the users with the name Josh, including the one we just created. And we can, of course, update the user using the put API. For example, we update the email as the example2@gmail.com. And if we execute it, and if we get the user again, it's gonna have the new information here. And we can, of course, delete this user using the delete API here. Okay, cool. And if we try to get this user again, it's gonna give an error. Okay, and let's talk about the songs API. It's pretty similar. If we want to create a song, we just enter the information of the song. For example, name, uh, a very good song. Talented artist. In the genre, for example, rock. If we execute it, it's gonna create the song. We can get the song by ID for sure. It's the song we just created. We can of course get all the songs. Yeah. And we can update the song using the put API. For example, like very, very good song. Let me just get the song again. Yeah, very, very good song. So it has all the information updated. And of course, we can delete the song. Let's delete it. Forget it again. It's gonna give an error. So combine the two domain models. That is what we do, like adding a song to a user's music profile. We add the song to a person's music profile using this put API. So for example, we just let's just pick a random user. For example, like Peter, we just copy his ID. we can take a look at this person's like music profile. So a couple of songs here. But for for example, if we just want to add a song to that user's music profile, for example, get a song, like a cool song like this one. We just copy the ID of the song here. We copy the user ID here too. Then this song is added to the user's music profile, and if we're viewing the music profile of the person again, it's gonna show here a cool song. And this also like uses the HidOS, so we are able to see the song's actual location. Okay, that's it for the user microservice. Let's talk about the concert microservice. This is our second microservice, the concert microservice. It's pretty similar. It has a cool API. For example, if we want to create a concert, we just post this payload, and if I execute it, let's create this concert. This one is gonna be visible in the get the concerts. Okay, and we also have its ID. We can use the get by ID to view this concert too here, and we can of course like update the concert using the put API. For example, uh, replace. If we update it, oh it says this concert is already. For example, change some information. We view this concert again. Big place, nice concert. Saw the new information. And of course, we can delete this delete this concert using the delete API. And if we get it again, it's an error because it no longer exists. Okay, that's it for the concert microservice. Oh, actually, like for the concert microservice, because there's a lot of concerts here, we implemented the pagination here. You can see it's a lot of concerts, very long list. So that's how we implemented the pagination. So for example, if I want the first page, and I want a page size of 5 concerts a page, if I execute it, okay, now we only show the first page of the concerts and there's only 5 concerts here. For example, like I'm changing to like the sixth page, and I want a page size, for example, like a 3. It's gonna show the 6th page, and it's gonna show a page of 3 concerts. So this is gonna make the response more readable because it's shorter. Okay, that's it for the concerts. It has pagination and it has CRUD APIs. And we talk about the third main microservice, that is the Finder microservice. In this microservice, we define a domain model called match. That is like we're like for a user attending a concert, we're gonna recommend some other users attending this concert to the user requested. And to store this kind of information, we're using the domain model match. We can add a match manually here. If we create it here, it's gonna create a match. And we can view the match in all the matches. And we can also like copy the ID and view it using the get. Yeah, and we can of course put the ID that is to update the update the match. For example, we delete one match here. It's only two matches now. If we get it again, see updated information. There's only two matches. And of course, we can delete the match. And if we get it again, it's gonna be an error because it no longer exists because we deleted it. So typical CRUD API for the match. But the main purpose of is microservices finder algorithm. This one is gonna recommend the users attending a concert to a user. So basically, this is a real user ID and this is a real concert ID. This user want to join this concert and just request our system to recommend other users attending this concert to the current user. So as we run this post in the Finder path, we're gonna recommend the users to the user requested uh, by creating a match data. And if we execute it, it's gonna run the matching algorithm. It's gonna create a match, and it's gonna also like show the KDOS link, so we can get more details about the match. Okay, this as if for the Finder microservice. Okay, I have that's it for the demo for the enhanced microservice implementation, and then I will demo the single sign-on and the front-end UI. So s- so basically, I'm gonna demo the front-end UI because like the single sign-on is part of the front-end UI. So this is the deployment of our front-end UI for our concert buddy app. If I log, yeah, this is the homepage of our app, and if we click the login, it's gonna take us to a website to do the Google's single sign-on. If we click the button to do the sign in, it's gonna call the Google single sign-on API, and I will be able to log in using my Google account, log into my current browser. If I choose this profile, it's gonna log me in using the Google SSO. As I logged in, it's gonna still request one more piece of information that is a birthday because it's an essential part of our backend API. So we have to submit a birthday to get started, and it has a default birthday entered here. If we submit the birthday, it's gonna create a profile in our backend. And after it's completed, it's gonna give us a button to get started. And we click get started, it's gonna take us to the dashboard. In the dashboard, it's profile details. It's a detailed profile, details of the current user, and it is created based on the based on the information in the Google SSO. For example, the pictures are the same as my Google account, and the name, email are the same, and the age is based on the birthday entered. And it's gonna display the songs added to the music profile of the user because I already like logged in before, so I have some songs I added before. And we also have a functionality to do the Spotify sync, that is to using a Spotify token to sync the songs from Spotify or the current user. But sometimes if someone don't have like don't want to use the Spotify token, if we can still use this functionality. If we click the Spotify sync, it's gonna use our default Spotify token to sync the songs from Spotify. If we click it, it's able to run the API to do the Spotify sync, and when it's successful, it's gonna show the status successful. And it's also gonna refresh the songs we just synced from Spotify. That's it for the profile details page, and we can explore concerts now. So when we want to look at the concerts, as we discussed before, it's a lot of concerts. So that's why we have the pagination here. So the default is the first page, and we have a page size of 5. If we view the concerts, it's gonna send the API to the backend, and it's gonna display the concerts in the first page with an entry of 5. Of course, we can change it. For example, the second page, and we want a page size of 6. It's gonna load it automatically. So, for example, if we're interested in this concert, it's gonna show the details of the concert and all the information that from our concert backend API. And in this current page, we can doing the match. So if we click this match button, it's gonna recommend the other users attending this concert to us, the current user. So if we click the match, it's gonna call the match API. When it's successful, it's gonna show it's successful, and we can view the matched users. Now these are the users matched to us, and we can view the detailed information of the matched user. I click their name. It's gonna take us to their profile, and these are the information of the matched user. And if you finish viewing one matched user's profile, we can go back to the list and look at the other one. And then the user will be able to contact this user with their email. And when you finish exploring the concerts, of course, you can get back to your profile to look at your profile, and you can switch between them. So it's like a dashboard. That's it for the demo. Thank you.
Hello, I'm going to introduce the implementation of our API gateway. We do this with the AWS API Gateway Service and Amazon Cognito. And we will attach our original URL to our API gateway with the integrations in the API gateway service. So any request to our API gateway will be redirected to this URL, and our original request will be sent to this URL, and it will be copy and paste in the Postman like this. Now we will say the configuration of our authorizer. We attached the Cognito client service to our authorizer with the issuer URL shown in this place. And now we will try to do the authentication with our Amazon Cognito account. We try to log in with this, and now we continue with our Google account, and we will be directed to the gwt.io website. And here is our GWT token. Now we copy this token to our header in the Postman, and we send the request to our endpoint. We can see that we successfully access our resources, and this is the authorized scenario. And now we will remove the red token and try with a random token like ABC23. And now we send a request, and we can find that our request has been rejected by the server. So this will be the unauthorized scenario.
This is the user microservice for our project. In the user microservice, I'm in charge of implementing the Spotify sync endpoint. So what this endpoint is going to do is it's going to get the user's playlist, and it's going to get all of the sound in the user playlist, and then insert all of those sound information into our database so that we can use it to match different users. And specifically, we have chosen to use the Spotify API. So this Spotify sync endpoint is going to fetch user playlist information from Spotify API. And as you can see, here is my Spotify account, and I have created this test playlist 1. And in this playlist, there are 7 songs. And I'm going to, and then basically when I hit the Spotify sync endpoint, it's going to relate this playlist into this user ID. And let's first look at this user ID. There's no sound under it because I just created this user obviously for the demo purposes. Doesn't have any sound, and yeah, no, there isn't any sound in the response body. It's empty. It's empty. And what I'm going to do now is I'm going to hit this endpoint, execute it. And as you can see, the response is 200. It has been successfully synced from the Spotify API endpoint. And let's execute this again, and see what song is under this user ID. This is the same user ID, by the way. As you can see now, in the response body, there are a lot of songs. There is the payphone, there's map, there's me and my broken heart, congratulations, rockstar, astronaut in the ocean, the box, which is exactly everything in this playlist. So everything, all of the information under this playlist has been synced and related to this user ID successfully. And yeah, that's it for the demo. Hope you like it. Thanks. Hi, this is Yutao Zhou. I'm in charge of implementing the entire Concert microservice for our project. And in the Concert microservice, there's a Ticketmaster sync API endpoint. So for this API endpoint, what it's going to do is it's going to call an external API, which is the Ticketmaster API. And it's going to fetch event from the Ticketmaster API and then insert those events into our database so that our user can use it to find a match. And let's first look at the log for Google App Engine, which is where I deployed my Concert microservice. So as you can see in the log, let it load a little bit. One sec. Yeah, as you can see in the log, there isn't much going on because nobody is using it so far. And what I'm going to do now is I'm going to try it out and hit this API endpoint. So at this point, it's actually the endpoint has been hit, and the Concert microservice is going to fetch information from the Ticketmaster API, which is an external API. And let's wait a little bit, and then we can see the insert. Yeah, now you can see it is inserting a lot of new data into our database, and there are a ton of them. That's why the log is like a little bit freezing. As you can see, there are a ton of log. Yeah, so that basically shows the API endpoint is working, and that's for the Concert microservice. Hi, this is Yutao Zhou. I'm in charge of implementing the CI/CD part of our project. And I have implemented these endpoints for CI/CD just for the demo purposes. As you can see right now, this endpoint is pretty simple. It's just returning this string, like saying this endpoint is reserved for CI/CD demo. And what I'm going to do is I'm going to change the code and then push it to the repository and to trigger the CI/CD part. So what I'm going to do is I'm going to say this endpoint is reserved for CI/CD demo, changed for demo purposes for CI/CD demo, just demo just like this. So also I'm going to change the unit test part, so the unit test wouldn't foul, so the deployment could be successful. Yeah, just like that. I have changed both the code and the unit test, and I'm going to push this to. I didn't save this file. Let me save it. Yeah. Let me push it to the GitHub for CI/CD, just like that. So I just push it to the main branch of the repository. So what that would do is that would trigger a cloud build event. So as you can see, the cloud build is currently going on. One sec, let it load. Yeah, so it's currently trying to build this new change and do the deployment. As you can see, it's triggered by the CI/CD and it's automatically triggered. So what is it going to do now is it's going to build the new app. It's going to run the unit test, and then it's going to deploy it to Google App Engine. So as you can see, it's currently building it. from my personal experience, our application usually take about 3 minutes to build. So let's be patient a little bit and wait for it. So after it is built, then it's going to deploy it to the Google App Engine, and if we wait a bit, then we can see the changes will actually being reflected in Google App Engine deployment. So as you can see, it has been about 1.5 minutes. So that's about 1.5 minutes to go. Yeah. So basically, whenever there is a commit to the Concert microservice GitHub repository, Cloud Build is going to realize that it is going to, and then it's going to trigger cloud deployment. So more specifically, it's going to do the following things as I wrote in this Cloud Build .yaml file. Let's make it smaller so we can see it. Yeah. So it's going to basically do these steps. First, it's going to do Maven. It's going to do a clean install, so every time it's fresh. And then it's going to run the test, run the unit test basically. And then it's going to do the app deploy yum. So that's basically deploy it to how we deploy it to Google App Engine. So as you can see, it's still building it, but it's pretty close to finish. As you can see, it's just building it by itself. It's pretty nice. I love it. Still building it. Nearly done. Let's wait for it. Yeah. But by the way, I would love to explain a little bit. Yeah, as you can see, the build has been successful around 3 minutes. As you can see, the installation log is all here. Everything has been installed. That's how long the build is successful, which is great. And here is everything for the unit test. I only wrote one unit test for demo purposes, and you can see the unit has passed. And then here's the deployment log. Is just like how the log would be when we do deployments on our own terminal by ourselves manually. So now it has already successfully finished the CI/CD part. So let's look at App Engine, look at the version, see whether all of the traffic has been directed to the newer version of the app. Because if after all traffic being sent to the new version, then we can test it. The result should then show. As you can see, all the traffic has been sent to this version. Let's see, what time is it? Okay, yeah. So this is when the Cloud build the new version of the app, and all of the traffic has been sent to it. However, there isn't any instance yet. It might need a little bit of time to spin up an instance automatically. Let's refresh it and see whether it will work. Yeah, here's the UI. Let's execute it. Yeah, as you can see, this is the newer version of the app. Now it's saying the endpoint is reserved for CI/CD demo, changed for CI/CD demo, which is what we just changed in the code. So the CI/CD part has been successfully implemented. So the unit test has passed, and it is working, as we can see in the log, and the continuous deployment is also working since it is deploying it successfully, and we can see this is actually in production. Like you can see, the URL here is from Google App Engine. Yeah, that's it. Thank you.
Hello, I'm going to introduce an example of our GraphQL service, and I will take users as an example. Firstly, let's have a look into our user schema definition. Here is our schema of user entity. And now we will look into our GraphQL configuration file. We can see that any query to our users will be directed to the getAllUsers method in our user query resolver, which has been implemented in this place. And it will invoke the getUsers function in our user service and fetch all the user data in our database. Now we will try our GraphQL query with this URL. We can see that our service has been deployed on the EC2 instance. We will copy this URL and access our service. Now we try with this query, getAllUsers method. We run the query, and we can see that we extracted the user information. And here is an example of our GraphQL service.